Hello everyone. In this question, it is given that if S be the sum of 1 upon 2 times the greatest integer value of square root of 1 plus 1 plus the term 1 upon 2 times the greatest integer value of square root 2 plus 1, and this goes on up to the thousandth term. Okay, the last term in this sum is 1 upon 2 times the greatest integer value of square root of 1000 plus 1. Okay, then we have to find the greatest integer value of this entire sum. Okay, this is the question. So we are given a sum where the first term is 1 upon 2 times the greatest integer value of square root 1 plus 1, and second term is 1 upon 2 times the greatest integer value, sorry, given 2 times this bracket here. Okay, the second term is 2 times the greatest integer value of square root of 2 plus 1, and this goes on up to 1000 terms. Okay, the last term being 1 upon 2 times the greatest integer value of square root of 1000 plus 1. Okay, so this can be simply written in a simple manner if I use the summation symbol of, let's say, n, which goes from 1 to 1000, and this can be written as 1 upon 2 times the greatest integer value of square root of n plus 1, right? So now if I take, say, k to be equal to the greatest integer value of square root of n, okay, then from the definition of the greatest integer function, it means that the value of k, it can be less than or equal to this value, right? The value of k can be less than or equal to the value of this square root of n, right? But this has to be less than the value of the next integer. Okay, so this is the definition of the greatest integer function. Okay, so from here, if I square both sides of this inequality, this becomes k square is less than or equal to n is less than k plus 1 whole square. Okay, and we are seeing that n goes from 1 to 1000. Okay, so for k equal to 1 in this inequality, okay, we get this 1 square is 1 square is less than or equal to n is less than 2 square, 1 plus 1 square, right? So this implies that 1 is less than equal to n and less than 4. So this means n can take 3 values here. It can take the value 1, 2 and 3. Okay, there are 3 values that n can take. Basically what this means is that the first 3 terms of the sum, okay, the first 3 terms, that is this is the first term, right? This is the first term, and the value of for this term will be equal to 1 upon, this is 1, so 2 times 1 plus 1, so this becomes 1/3, right? Similarly, for the second term, the greatest integer function of square root of 2 plus 1, again square root of 2 is 1.41 something, so greatest integer will again give back 1, so this is again the same value 1/3, and for the third term also this is going to be, this is 1.73, right? So this is again going to be equal to 1, so this is again 1 upon 2 times 1 plus 1, so this is 1/3. Okay, these are the 3 values for k equal to 1, so this represents the first 3 terms of the sum. Okay, so these are the 3 terms, so if you multiply them, sorry, if you add these terms, there are 3 terms here, so the first 3 terms will be 3 times 1 upon 3, right? So this gives a sum of 1. This is the sum of the first 3 terms here. Similarly, this is just for k equal to 1. Similarly, for k equal to 2, the equation was k square is less than equal to n, right? So for the second term, this will be 2 square will be less than or equal to n will be less than equal to 2 plus 1 square, so which is 9, 3 square, right? So this implies that n can take the values 4, 5, 6, 7 and 8. Okay, so it can take 5 values for k equal to 2, which means I'm referring to the next 5 terms of this sum. Okay, these are the first 3 terms. I'm referring to the next 5 terms of this sum here. Yes. Okay, so I will show you 1 or 2 examples for this one also. So the first one is going to be this one. So square root of 4 is 2. So greatest integer value will remain 2. So this becomes 2 times 2 plus 1. So this becomes 1 upon 5. The next one is 2 times greatest integer value of root 5 plus 1. Again, this is 2 point something. So this will again remain like this. 2 plus 2 plus 1. 1 upon 5. Okay. And the term after that, this is also 2 point something. Okay. So this again is going to be 1 upon 5. Okay. Now, in the first case, there were 3 values. Here, I have done it for 4, 5, 6. For 7 and 8 also, this is going to be the exact same value. Okay. So, for this entire 5 values, for 5 values, the sum will be 5 times. There are 5 times here. Okay. So, for 5 times, each time you get the value of 1 upon 5. So, the entire sum will be 5 times 1 upon 5. So, this is 1. Okay, so we got 1 for this first 3 terms, then we got 1 for the next 5 terms. Okay, now this goes on for k equal to 3. I will show you. This will become 3 square will be less than equal to n, will be less than equal to 4 square. So this implies n can take the values from 9, 10, 11, 12, and it goes on up to 15. Okay, so here there are 7 values. 7 values here. Okay, so this goes on, and for I will show you one example here. Let's say I'm taking this value. Okay, 10th term. So this will be equal to 1 upon square root of 10 is 3 point something. So greatest integer will give you a value of 3. So this becomes 1 upon 7. So you see a pattern here, right? Here are 7 values here, and each value will be equal to 1 upon 7. So sum will be 7 terms, each having the value 1 upon 7. So sum is again 1. Okay, so this is the pattern here. For each k equal to 1, 2, 3, 4, we are getting the entire sum to be equal to 1. Okay, so the last term is 1000. Okay, now last term equal to, sorry, okay, now this square root of 1000, we have 30 square equal to 900, and we have 31 square is equal to 961, and 32 square will be equal to, I think, 1024. Okay, so this one exceeds. So this square root of 1000, square root of 1000 is somewhere between this 31 and 32. Okay, but if you take the greatest integer value of this value, then it is equal to 31, right? That is, this is 31. It will be more than it is more than 961, but the greatest integer value will be equal to 31 here. Okay, so the last term will be your 1 upon 2 times 31 plus 1. Okay, now we have to find how many terms are there. So if we look for k equal to 3, going on, this will go on up to k equal to 30, let's say. Okay, for k equal to 30, there will be 30 square less than or equal to n less than or equal to 31 square. So this implies there will be 900 is less than equal to n less than 961. Okay, so this implies there are going to be, if I start from 901, 901 being the first term, there will be 61 terms. Okay, so since 961 is excluded and 900 is included, the total number of terms are going to be equal to 61, right? We are taking one and removing another. So there are total 61 terms for which the value is going to be equal to, you take any value here, 1 upon, let's say, this one, okay, in the sum here. This will be equal to, this is going to be square root of 901 is close to 30. So this will be the value 2 times 30, the greatest integer value, and this fraction will be equal to 1 upon 61. And see again, there are 61 terms here. So the sum of all these 61 terms will be again equal to 61 times 1 upon 61, right? So this is 1. So we see there are 30 terms here, k equal to 1, k equal to 2, k equal to 3. We are getting s equal to 1 plus 1 plus 1. This is for k equal to 1. Let's say this is for k equal to 2. This is for k equal to 3, right? And this goes on up to k equal to 30. Okay, so we are getting 30 here. And for k equal to 31, we have to look separately, okay, plus some extra terms, okay. So this 30 is confirmed. Now some extra terms are there for k equal to 31, okay. So for k equal to 31, we have 31 square less than equal to n less than equal to 1000, right? So this implies that n goes from 961 and it stopped just before reaching 1000, okay. So this implies there are going to be, if I started from 961 being the first term, then it would have been 40 terms, right? 40 terms, but if I write it, let's say the terms are going to be 961, 962, and actually my bad. Okay, it can actually include 1000 also, since the disjointing part will be 1024, right? It stops much before that, so it can take the value 1000 also. So no issues here. It goes up to 1000, which means there are going to be 40 terms here. Okay, I was confused for a bit here. So it goes on up to 40 terms, right? So the sum of any of these terms will be, let's say, I take the value 963. Okay, I'm taking a particular term here. This is going to be 1 upon 2 times. This is 31 point something. So the greatest integer will be 31 plus 1. So this will be 1 upon 63, right? So the sum of all 40 terms will be equal to 40 times this 1 upon 63. Okay, so this is 40 plus 63. So this is the extra terms. Okay, these extra terms, this is equal to this 40 upon 63, right? So we have completed almost. Now S is this 30, which we have reduced here. See, this is the, we get each one value for k equal to 1, k equal to 2, k equal to 3, up to k equal to 30. Okay, and for k equal to 31, we get the sum to be equal to 40 upon 63. Okay, so this is the entire sum. Now we are required to find the greatest integer value of this sum. Okay, so this is going to be 30 plus 40 upon 63. Now this value, this is strictly less than 1, right? This is less than 63 upon 63. So this is between 0 and 1. Okay, so this means this is 0 point something, like it will be maybe 0.63, I don't know exact value. Okay, something like this. So this is 30 point something. So again, this final value will be equal to 30, right? The greatest integer function, this will give back 30. Okay, so this is the final required answer. Okay, Okay, I know this was a very lengthy question. I wanted to just show all of these summation cases individually, okay, for a bit more examples and bit more specificity. Okay, but if you can understand the pattern, you can do it in much fewer steps. Okay, you don't need to show all the steps in the exam if it ever comes. Okay, I was just doing so that if you try this sum, you can understand what is going on. Okay, so I hope this was useful in my explanation. If you believe there are any limitations, you can highlight in the comments also. And if you believe there are any mistakes, you can also highlight it in the comments. Okay. So this is finished here. This is the final answer. The answer is 30 here. Okay. So thank you for watching.